Most gardeners try to fix dead soil by dumping fertilizer on it. That's the fastest way to stay stuck. You get a short burst of green growth, then weaker plants, more pests, tighter soil, and by the next season you're adding even more inputs just to get the same result. I've seen this cycle in backyard beds, raised planters, and even large market plots. The soil isn't hungry for fertilizer. It's missing structure, biology, and carbon. If you're serious about growing food long-term, subscribe to the channel because we focus on systems that actually rebuild soil instead of propping it up. Dead soil is not a nutrient problem, it's a biology problem. When I say dead soil, I'm talking about ground that's compacted, low in organic matter, drains poorly or dries too fast, and produces stunted crops even when fertilized. The common thread in every case I've tested is low microbial activity and almost no stable carbon. In one backyard plot I worked on, tomatoes were yellowing despite regular synthetic feeding. We ran a simple soil respiration test and found almost no biological activity. Organic matter was under 1.5%. That's not soil functioning as a living system, that's just mineral substrate holding roots upright. Restoring that soil had nothing to do with more NPK. It required rebuilding the carbon base and feeding microbes consistently. Compost alone is not enough if you don't change how you apply it. A lot of advice stops at add compost. Compost is important, but dumping half an inch on the surface once a year won't revive truly degraded soil. In severely depleted beds, I've had the best results incorporating compost at a rate of about 25 to 30% by volume into the top 8 to 10 inches during the first restoration phase. That's aggressive, and it's intentional. For a 4x8 raised bed that's 12 inches deep, that can mean adding 6 to 8 cubic feet of high-quality compost in the first season. But here's where most people go wrong. They till it in repeatedly every season, which destroys fungal networks and collapses soil aggregates. I incorporate once during restoration, then shift to top dressing only. Disturbance is the enemy of recovery. You need carbon that lasts longer than one season. Compost breaks down quickly. If you want real restoration, you need stable carbon. That's where biochar or partially decomposed woody material comes in. In one compacted clay bed, I incorporated biochar at roughly 5 to 10% by volume, pre-charged with compost tea and diluted fish hydrolysate. Never apply raw biochar directly. It will temporarily tie up nutrients. I soak it for at least 48 hours in a nutrient solution before adding it to soil. Within one growing season, water infiltration improved dramatically. Instead of pooling on the surface, irrigation soaked in evenly. Earthworm activity increased noticeably by the second season. If biochar isn't available, shredded hardwood fines or partially decomposed wood chips mixed into the lower soil layer can perform a similar function, though they break down faster. You can't fix dead soil if you keep leaving it bare. Bare soil is an emergency state. Sunlight oxidizes organic matter, heat kills surface microbes, and heavy rain compacts unprotected ground. Every restored bed I manage is kept under at least 2 to 3 inches of mulch year-round. Straw, shredded leaves, or arborist wood chips all work. In vegetable beds, I often use partially composted leaf mold because it feeds fungi while protecting the surface. In one test plot, I left half the bed bare and mulched the other half. After 3 months of summer heat, the mulched side retained nearly double the moisture at 4 inches deep. Microbial activity readings were significantly higher as well. Mulch is not decoration, it's a biological shield. Cover crops are not optional in serious soil recovery. If you really want to restore dead soil, you need to grow roots in it as often as possible. Bare beds between seasons, honestly, just slow recovery. In open ground gardens, I rotate heavy feeding crops with cover crops like cowpeas, crimson clover, or daikon radish, depending on the climate. Legumes fix nitrogen, but actually, more importantly, they feed soil microbes through root exudates. When I terminate a cover crop, I cut it at the base and leave the roots in the ground. Those decaying roots create channels for air and water while feeding fungi underground. In one exhausted, sandy plot, planting a dense cowpea cover for 10 weeks increased organic matter measurably by the next season. That's not theory, that's lab-tested change. Raised beds require a slightly different approach. They lose organic matter faster because they drain quickly and warm up faster. Restoration there, well, it needs heavier initial inputs and stricter moisture management. When I'm rebuilding a depleted raised bed, I mix compost at 30% by volume, add 5% biochar, then maintain moisture carefully for the first 2 months. Microbes really need water to establish. Letting a newly restored bed dry out repeatedly will slow biological recovery. After the first season, I reduce compost additions to 1 to 2 inches, top-dressed annually, and let biology take over. Hydroponic growers still need to understand soil principles. Even though hydroponics doesn't use soil, the principle of biological balance still applies. Sterile systems often require constant correction because there's no buffering capacity. In media-based hydrosystems, adding a small percentage of biochar to cocoa coir has improved moisture consistency and root health in my trials. It acts as a micro-reservoir and habitat for beneficial microbes if you're running a biologically active nutrient program. The lesson is consistent across systems. Stability comes from structure and biology, not constant feeding. Stop chasing quick fixes and start building layers. Dead soil doesn't recover overnight. In severely degraded ground, it can take 2 to 3 seasons of consistent carbon inputs, cover cropping and mulch before you see dramatic changes. The mistake is expecting immediate transformation and then abandoning the process. Soil restoration is cumulative. Every root left in place, every mulch layer, every compost application adds to long-term function. I've restored compacted subsoil that initially grew nothing but weeds into productive vegetable beds within 3 seasons. Not by force-feeding nutrients, but by rebuilding the system from the ground up. There are trade-offs you need to understand. Adding high levels of organic matter can temporarily increase pest pressure if balance isn't maintained. Too much undecomposed material can tie up nitrogen. Overwatering during restoration can create anaerobic pockets. That's why I emphasize balance. Stable carbon at 5 to 10%, compost at 25 to 30% during initial rebuild, consistent mulch at 2 to 3 inches, living roots as often as possible. It's not about copying a formula blindly. It's about understanding why each layer exists. Healthy soil becomes low maintenance over time. Once soil biology is re-established, irrigation frequency decreases. Nutrient deficiencies become less common. Plants handle stress better, yields stabilize. That's when gardening shifts from reactive to proactive. Restoring dead soil is not a genius trick because it's complicated. It's genius because it respects how soil actually works. Carbon feeds microbes. Microbes build structure. Structure holds water and nutrients. Plants thrive. If you value that kind of practical field-tested knowledge, subscribe to the channel and share this video with another grower who's frustrated with tired soil. Growing better food starts below the surface, and the gardeners who understand that are the ones still harvesting strong years from now.